Now, guys, we have to study the proof by induction. Okay, so before I tell you about this proof by induction, I must tell you that there are many ways of proving the given statement. One with which you people are quite used to, that is the proof by deduction. Okay, you may not have heard about this, but you have been using this proof by deduction. Now, this is, for example, when you have the trigonometric identities. For example, you have to prove that sine theta, cotangent theta is same as cos theta. So you will be starting from the left hand side, okay, and you will doing all this working like you will say, okay, this is going to be cos theta over sine theta. So these are cancelled. So you have this cos theta, and that is equal to the right hand side. So this is a proof by deduction. Then there is one more, which is proof by contradiction. This is, by the way, my favorite, okay? Proof by contradiction. Um, in this, you are, for example, you have to prove that this is a very famous question. You have to prove that under root 2 is an irrational value, okay? This is an irrational number. Okay? So rather than proving that this to be an irrational number, you will try to prove that this under root 2 is rational. Okay? And you will fail in proving that this is, there is a whole procedure. I don't want to go into that. Okay? So you will try to prove that this under root 2 is rational. So you will fail to prove that this is a rational number. So this would mean that under root 2 is an irrational number. So that is proof by contradiction. Then there is another very famous method of proving the given statement. That is proof by exhaustion. Okay. Now, suppose you have to prove that n cube minus n for any positive value of n, this is never going to be this is never going to have 6 as a factor, or this is never going to be a multiple of 6. Okay, so you will have to try with many values. You will have so many cases. Okay, you will try with 2, with 3, and all of that, and you will, you can guess from its name that for this you have to try many different values to prove that given statement. Okay, so I'm coming to this proof by induction here. Now, you have briefly seen that what were these proofs, how to prove by deduction, prove by exhaustion, and then prove by contradiction. So we must know that how do we prove the given statement when we are using the proof by induction. Okay, guys, the proof by induction basically has 3 steps. You will be proving the given statement through 3 steps. Okay, by the way, you can be asked to prove a given statement regarding a sequence. Okay, regarding a series. There can be the divisibility cases, okay? Divisibility, I hope my spellings are right, okay? Divisibility, and then there are a bit of matrices are also, you can have a question to, a statement regarding all these 4 can be there that has to be proved by induction. Okay, now let me tell you its story first, and then we'll go into its questions. Now, what happens is, guys, okay, as I was telling you, there are 3 steps. First of all, you will say, okay, you will prove that your given statement is true for n equal to 1. You will prove the statement true for n equal to 1. And then you will assume that the statement is true, the given statement is true for n equal to k. And then in the third step, you will prove that the given statement, it is true for n equal to k plus 1. Now, this is the main step over here where you have to be very good at algebraic manipulation and all these concepts of sequences, sum of the series and the divisibility and all these matrices. Okay. Now, the story is that, now suppose if I show you, like, there are, like, this is 1, there is 2, there is 3, there is 4. I have just drawn a number line. In fact, I wanted to, so this is, there are numbers 1, 2, 3, 4, 5, and so on. If you have proved that your statement is true for 1, okay? And when you assume that it is true for n equal to k, and then you're shown that this is true for n equal to k plus 1. So then it means if it is true for n equal to 1, this implies that your statement will be true for 2 as well. Okay. And if it is true for 2, then this will be true for 3 as well. If it is true for 3, this will be true for 4. So that would mean that this given statement is going to be true for all the values that are given to us, for which we prove that this is going to be true. Okay, so there are 3 steps. You will prove, first of all, for n equal to 1, then you will assume that this is true for n equal to k, and then you will be proving that this is going to be true for n equal to k plus 1, and then you will be writing the conclusion at the end, which is really important, and I'll tell you how to write it. So in the next segment, I'll be taking some examples from the series thing. Okay, so let's go into the next segment.